In this screencast, we'll talk about drawing Lewis dot structures. So we're going to follow up our discussion on assigning electron configurations from our abbreviated periodic table. Just as a review, the numbers in red here are the group numbers. Remember, the groups are the columns in the periodic table. So hydrogen and lithium are 1, beryllium is group 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, helium 8. So these are the noble gases. So keep in mind that the periods are the vertical rows in the periodic table. So we've assigned helium as having the electron configuration 1s2. Alternatively, that can be abbreviated as brackets helium. So we know that the elements sequentially add 1 electron. So everything in the second period is going to have this helium electron configuration for the core electron. So that's an important point. So as we start adding electrons to lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, these electrons that we add are going to be the valence electrons. And the valence electrons are going to be the ones that are contributed to the Lewis dot structure. So for example, let's go ahead and look at lithium fluoride. So here's the molecular formula, lithium fluoride. Now we want to draw the Lewis dot structure, which means we want to understand how these two elements are bonded together. So to do that, we need to know what each element contributes in terms of the number of electrons. So we're going to look at the electron configuration for lithium. Lithium will be helium. Those are the core electrons. Now we're in period 2. That's the shell. We're going into the lowest energy orbital, which is S, and it's atomic number 3, so we're putting in 1 electron. So that has a total of 3 electrons. We're going to signify that electron as a dot on lithium. If we do the same for fluorine, we see that it has the same core electrons as helium. Then from the group number, we can tell how many valence electrons there are. There are 7 valence electrons. So let's go ahead and assign those. 2s2, and now we go into the p orbitals. So this is going to have 5. So that gives us our 7 valence electrons. Those valence electrons we're going to represent as dots around fluorine. So we're going to do it in this fashion. We're going to add 1 at the top, 1 to the east, 1 to the south, and 1 to the west. So this is going to represent unpaired electrons. So there's 4 of them. We're going to start now pairing the electrons. Here's 5, 6, and 7. So we see that fluorine has a total of 7 valence electrons. We have 1 unpaired electron. So to draw the Lewis dot structure for lithium fluoride, we're going to pair the unpaired electrons. So we draw lithium. There's its unpaired electron. We draw fluorine. And now we pair that electron with lithium. So that's a Lewis dot structure. So these 2 paired electrons represent a chemical bond. This happens to be an ionic compound. It's ionic because the difference in electronegativity based on the Pauling electronegativity scale is greater than 2. So we have fluorine and lithium. They're sufficiently separated on the periodic table that in this compound, fluorine actually owns all of the electrons. So another way we can represent this compound is in a salt form. With positive and negative charges. So we're going to talk about formal charges and how we assign those as well in another screencast. But keep in mind for now, the reason that fluorine owns the electrons is due to the electronegativity of fluorine. Now let's examine a carbon-based compound. So organic chemistry is going to be primarily focused on the chemistry of carbon. Carbon is in group 4, so it has a total of 6 valence electrons. Let's go ahead and look at the simplest hydrocarbon here. So this molecule is called methane, CH4. That's the molecular formula. So carbon has the electron configuration of helium. And then in period 2, we have 4 valence electrons. So 2s2, 2p2. So we have a total of 4 valence electrons. Now those valence electrons are going to be the ones that contribute to the Lewis dot structure. We're going to put one in the north, the east, the south, and the west. So notice how I did that. They're at this point, they're all unpaired electrons. Now we're going to examine hydrogen. Hydrogen simply has the electron configuration of 1s1. So hydrogen only has 1 electron. Let's just go ahead and arbitrarily put that electron here. So to draw the Lewis dot structure, this single carbon is going to be bonded to 4 hydrogens. So let's go ahead and draw in our carbon. Now we're going to pair that carbon with 4 hydrogens. So we're going to pair each of these electrons. So there's 1 hydrogen. We're going to pair this hydrogen now, this hydrogen, and finally 4. So we know that 2 electrons make a bond. So this is the Lewis dot structure. And what we'll notice is that if we count the number of electrons around carbon, carbon has 2, 4, 6, 8 electrons. So that's pretty important for all the elements to have 8 electrons. That's called an octet. So hydrogen only has 2 electrons. That's based primarily because it's in period 1 here, and it's not able to accommodate 8 electrons. So all of the other elements that we deal with will have an octet. So part of the drawing the Lewis dot structures is ensuring that we have the correct number of electrons. So we can do a check as well. So we have 4 hydrogens. That's 4 electrons there. We have 1 carbon. That's 4 electrons. So we need to account for a total of 8 electrons in our structure, and we've done that. We have 2, 4, 6, 8 electrons. So this will wrap up our introduction to Lewis dot structures, and we'll consider in a second screencast more elaborate organic molecules, where we start using elements other than hydrogen.